Hey guys, we continue doing logarithmic equations and proofs, and this is the hard level. That's for GCSE, iGCSE extended definitely, and this revision with Daniel Dallas. Let's get started. So you've got first two challenging problems you need to solve for x, and the first equation is definitely exponential one. So try to do by your own, and let's compare it with my explanation. Alright, so what we're gonna do, we're just simply try to have a look and understand the structure, because definitely you are not able to do anything with two different bases, 4 and 2. However, they have the same power. If it were in 3, you can do probably by division and in the previous case. So let's have a look at the structure. Instead of 4 to the power 2x, we'll try to arrange the following. So 2 to the power 2x, and let's say squared, because 4 is 2 squared, and we can rearrange the powers, okay? So that's why on top of that, you subtract 2 to the power 2x, and I try to separate this 2 to the power 1, and I transfer 3 to the left hand side. Let's have a look at the structure. Now it's pretty much more obvious that it's sort of quadratic one. So if you make rechange, so you input new variable t, which is equal to the power of 2x, you'll get the following, that this t squared minus 2t and minus 3. You definitely have purely quadratic equation. Now this is quadratic, and you can solve that. But before, I strongly recommend to, once you mark t as new variable, you understand that restrictions for t is that t is strictly more than 0, because no matter what stays for x, 2 to the power of 2x will always give you a positive number, even if x is negative. If x is negative, it's just flipping the over the fraction. So it flips over, but it doesn't change the sign before it. So that's why we're going to use quadratic solution, and t squared minus 2t plus minus 3 can be factorized in the following manner. So t minus t plus 1 and t minus 3. If you expand back, you will get back to your original one. So we factorized, and from where we have two solutions. t1 is -1 and t2 is 3. From where you definitely understand that you need to discard t1 because of the restrictions. So that's why you will have 2 to the power 2x will be equal to 3. And now you're going to use logs to both sides. So you apply logs to both sides here, okay? That's sort of the final exponential equation that you need to solve. So you apply log with the base 2 to both sides. And if you apply it to the left side, you'll get simply 2x. While on the right side, you'll get log 2 of 3. So that's why finally x is going to be 1 over 2 log 2 3. If you want, you can rewrite as log 2, and this 1 over 2 goes as the power to 3, so it means make square root of 3. But no matter which form you like, you can rearrange if you want to get your final answer by calculating. So just you calculate. If you leave in terms of logs, that's also okay. It depends on the question. So I leave for a while, but you know what to do in case you want to give answer as the decimal, no problem. And first is completed. Let's go to the second one. So we've got 2 log x plus 3, 2 log 3, and log x plus 1. So what we're going to do, we're trying to combine all logs with x's in the left hand side. But before, so 2 log x plus 3, I would like to write as log x plus 3 squared. Alright, and I transfer log x plus 1. On the right side, I will get log and 2 goes as the power 3, so means as a power to the base 3, so that means it's 3 squared, which is 9. Okay, so what we're going to do, we use the rule for subtraction of logs, and we simply rewrite as x plus 3 squared over x plus 1. That's going to be a number which stays under the log expression. And on the right side, we just write log 9. Okay, now we eliminate both logs. In this case, you just simply can rewrite as x plus 3 squared over x plus 1 equals to 9. Okay, so what to do next? Just simple fractional equation. So what we can do here, we just simply can multiply by x plus 1, having the fact that it's not equal to 0. So obviously it's not 0 just by definition, because instead of x plus 1 there's the expression under the log, and means x plus 1 strictly more than 0. So that's why we use this fact and we multiply both sides by x plus 1, and simultaneously we expand x plus 3 squared. So we're going to use the formula as x squared plus 2 times 3 times x, 6x, and plus 9 will be equal to 9x and plus 9. I expand also 9 by x plus 1. And what you can see that 2 9's can be cancelled. They can be freely eliminated. And that means you'll get x squared and minus 3x equals to 0. Then you factorize x minus 3, and you equate to 0. So final solutions for that, either x1 equals 0, that's the first solution, or x2 equals 3. And now you need to check whether both legible or only one. If you plug 0 everywhere instead of x, you'll get pretty nice expression. I mean, it doesn't violate logarithmic rules. So x freely 0, no problem, as well as x equals 3. So that's why here 0 and 1 can be considered as solutions for your your second logarithmic equation. So the second part is also done. Hope you like that. That was pretty easy. And let's go to the next one. So you need to prove here, that's the proof, that solution of 9 to the power of x equals 16 is a rational number. Okay, so first of all, let's try to set up the solution for a 9 to the power of x equals 16. That means if we apply log to both sides with base 9, we'll get x equals to log 9 16. Okay, so that's the solution. However, how you can check? There is no way except for using calculator, but anyway, it's not the proof, right? You need to prove somehow algebraically, because your calculator has the limit accuracy, so it will give your number, the answer for x, to a certain extent, like to of the digits. So that means it's not the proof. And you know that a rational number, you cannot predict the rule of how next digit occurs in the number. So that's why we need to prove somehow another way. I will use the proof from contradiction. So that's why I'm going to say that from contradiction, proof by contradiction, not from, but sorry, proof by contradiction. By contradiction. This way of proof you definitely will use in your A-level stuff when you're gonna trying to prove using induction method or by contradiction. So in this case, by contradiction, we can say that, let's assume that x is a rational number. So let's pretend, so assume that x is rational. a rational number. That means if it's rational number, it means that x can be represented. So in other words, we're going to say that x from q. So we can say that x can be presented as, let's say, p over q, right? With both p and q are from integers, and q is not going to be 0. That's what rational number by definition. In this case, we can state that 9 to the power p over q should give us 16. All right. So what we can do, we can raise to the power of q. So raise to the power q, both sides. In this case, you'll get 9 to the power of p will be equal to 16 to the power of q. All right. Or another way you can write using the prime basis. So if you use prime numbers instead of 9 and 16, you can rewrite as 3 to the power 2p, and here is going to be, so 16 as 2 to the power 4, right? So 4q. In other words, if you mark 2p as m and you mark 4q is another n, the m and n both going to be still integers, and that means you'll have the following equation. 3 to the power of m will be equal to 2 to the power of n. But there is no way, because if you transfer 2 to the power of n to the left hand side, and you'll get 0 on the right side if you try to factorize, because only by factorizing you can get 0 as the result. But there is no way, because 3 multiplied by 3 multiplied by 3 occurs, let's say, m times, yeah? While 2 to the power of n occurs multiplying itself, so n times. And there is no way to get 0, because there is no way to factorize somehow, okay? So that's why 3 times 3 times 3 never be equal to 2 times 2 times 2, because they are different prime numbers. And that means it's impossible. So it is impossible. So that's why you actually arrive to contradiction. That's why it's called contradiction. So it contradicts to the fact that it should be 0 on the right side. So that contradicts the resultant statement that 3 times 3 to the power of m minus 2 to the power of n equals 0. So that's why it's impossible. So that's why it's impossible that x is going to be a rational number. So we proved that x is actually a rational number. All right, so you can do in the same way b part, but you're wrong, guys. So you need to prove that exact value of the expression log 2 3 is also irrational. Try to do but you're wrong. Share in comments what you get and the way you prove. But the hint here is to use the same principle, okay? So that was complete theory for, or theoretical basis with practice with revision for logarithm. Try to rewatch all the basics if you forget how rules works. But if you're on a challenging problem, I hope you understand how it works. And guys, thank you. Don't forget to visit Zillion's A-level class for A-level stuff explanations. So I'm going to do the same to enrich the collection of videos that we have on both channels. So try to check both channels. If you're new here, subscribe. Don't forget to smash the notification bell button to be notified on a daily basis. And see you next time.